Assalamu alaikum. So in this video I will be performing the part 2 of my DLD Lab 4, which is in which I will be executing two Boolean functions and creating their circuits and viewing their waveforms. So these are the two expressions here: f1 a bar b plus c bar d and f2 a bar b bar plus c bar d bar. So I'll be implementing these two and we will be creating the code for these two expressions. So first of all, I have created here a new project and named it Boolean. So in the first part I showed you how to create a new project. So similarly I created a new project, and let's start. First, in starting the code, I will write module and then our file name Boolean, and then the variables that we need for this code. So we can see in the expression there are 4 inputs A, B, C and D and one output F1. So A, B, C and D, 4 variables here for the input and one for the output, it is F1. And similarly for the second expression, again A small, B small, C small, D small and F2 for its output. So here are all the variables that we will be needing. Then let's declare our inputs. So input A, B, C, D and A, B, C, D, and our outputs A, B, C, D. Sorry, not A, B, C, D, F1 and F2. So F1, F2. Now I'll be creating the code for the first expression F1. So assign F1 equals to, so let's look at the expression once again, A bar B, so which means A bar means not A, and multiplication means AND, so AND B. Let's put it all in a bracket. Then plus, so we have a not OR gate in between for plus, and then again not C, which is complement C, and multiplication, so again AND D, bracket here. So this is our expression F1 done. Now let's move to the second expression. Again assign F2 equals to, again this time we have our expression as A naught B naught plus C naught D naught. So A naught and C naught, sorry, B naught, yes, B naught, all in a bracket. And then plus sign between, so OR gate here, again C naught and D naught, all in a bracket, and the semicolon at the end. And now we will end module and end our code here. So I think we have successfully written the code. Now let's see if it's working or not. So start compilation, click on yes. I hope we have no errors. It will take a while to compile, so we'll wait till then. The compilation is done and it was successful. let's view the circuits. Right click on Boolean, then locate, and then locate in RTL viewer, and we can see both of our circuits are here implemented correctly. You can see that the correct circuit diagram is also correct. So now let's look at their waveform. So here we'll go on new and then university program VWF. Here let's insert node, go on node finder, go on list. So let's select first circuit variables here, all of them. So let's give them, change the time period so that they are a bit more observable. This one 50, 100, we need twice the numbers, twice the time period, so 100, and 200 here, again twice of 100, and D 400, and the last one 800. So here we can see we have all the possible combinations of the 4 input, like 0 0 0 0, 1 0 0 0, 0 1 0 0, 1 1 0 0, and similarly till here we will have all the possible combinations till here. So now let's run this and look at our output waveform, which will basically be the truth table of this circuit. Okay, so here is our output. Now let's see if it matches the truth table here, which is of the F1. So we can see we have 1 at when only D is 1. So let's see when D is 1, D is here. So when D is 1, we can see that the output is, here is the output 1. Okay, now let's look for another. Here we can see when B is 1, the output is 1. So let's look for B is 1, all others are 0, output is 1. Again you can see it here. Now let's look at this one, T is 1, B is 1. Okay, so B is 1 and D is 1, we have here output 1. So similarly we will tally our truth table, we will get to see that our waveform is correct, and we have successfully created this F1 expression circuit. Similarly, to now view the waveform of the second F2, just delete all of these nodes here and go again on insert, node finder, list, this time all the other all the second F2 expression inputs here. Okay, change their periods, time periods. So I have changed all the time periods of all the inputs and outputs. Let's see the output waveform here. And here we have the output of our F2 expression. So we have now viewed created both the circuits of both the expressions and viewed their waveform, and this is all for this lab. So we have done all our tasks for this lab and covered all our objectives. Thank you.